I want to finish off the section here talking about differential equations, a specific type of differential equations called separable differential equations. And really, the ones that we've already done fit into this category. So all the exponential growth and decay problems that we just worked on were a type of separable differential equation. But there are also some separable differential equations that don't result in exponential growth or decay. So I want you to at least have seen one of those. They're generally, well, I don't know if they're easier or harder, but they're generally a little bit simpler. But I just wanted to make sure that you saw one before I kind of threw you in and working on some. So the process that we're going to use for all these problems are exactly the same as the process that we talked about earlier. We're going to separate the variables. We're going to find the antiderivatives. We're going to include our plus c. We're going to use the initial conditions if they're given to us to find the value of c, and then we're going to solve for y. So if we're given initial conditions, then we will be asked to find the particular solution. And when we're asked to find the particular solution, all that means is we actually want to find the value for c. And if not, if they don't give us initial conditions, we won't solve for c, and that will be the general solution. Okay, so for the particular solution, we're going to be given initial conditions and asked to solve for c. But for the general solution, we won't be given initial conditions, and so then we can't solve for c. So let's look at an example, and we'll do the general solution, and then we'll do the particular solution for this example. So the example that we're going to talk about is dy dx equals cosine of 2x over y. Okay, and so we're going to find the general solution. And we're going to start by separating the variables. So I multiply the y over here and I multiply the dx over here. So I get all the y's on one side and all the x's on the other side. Now I'm going to integrate both sides. And when I do that, I'm going to get y squared over 2 on the left. And here I kind of have to use some u substitution. I'm going to say u equals 2x, du equals 2dx, and then when I do the integration, I'm going to get 1/2 sine of 2x. So I have y squared over 2 equals 1/2 sine of 2x plus c. And I'm not going to solve for c because I'm only finding the general solution. So I'm just going to solve for y. I'm going to multiply both sides by 2, and then I'm going to take the square root and solve for y. So this right here is my general solution for the differential equation dy dx equals cosine of 2x over y. Alright? So we take that idea, if we're asked to find a particular solution. So if we are asked to find a particular solution, they're going to give us initial conditions. So say the initial conditions that we're given are pi over 4, comma 3. So x equals pi over 4, y equals 3. So our first few steps are going to be exactly the same. Right? We're going to separate the variables, integrate both sides, and we're going to get our antiderivatives. Right? So I'm going to start right from that spot. You can see I followed the same process, and I got to there. All right? The difference here is that we actually want to solve for c. And we have some choices about when we solve for c. In general, I would say it's usually easier to solve for c before we go and actually solve for y as we did down here. You can see that if I wanted to solve for c here, I could plug in the x and y values, but I'd have to square both sides to get the c in a place where I could isolate it and solve for it. Right? I don't have to do that here. I can multiply by 2 first, just to simplify that thing a little bit. So I get y squared equals sine of 2x plus c. You'll notice here that I multiplied by 2, but I really didn't change this variable at all. So this is not really the same c. We call it c again. If it makes you feel better, we can say initially this is c sub 1, and then after we multiply through by 2, now I just have a plus c. That works fine. But the important part for me to remember is whenever I decide to begin finding c, in other words, when I decide to plug my x and y values in, this is the c value that I'm going to find. And so when I plug that c value in, I have to plug it into the correct place. Okay, so when we get to the end, we'll talk about kind of a little bit more about what I mean by that. So I'm going to choose this step to start solving for c because I have a c. It's nice and it's going to be really easily isolated. So it's a nice place to start doing that. So I'm going to plug in my y equals 3 and my x equals pi over 4. And then I'm just going to solve for c. So I evaluate this. This is 2 times pi over 4 is pi over 2. 3 squared is 9. The sine of pi over 2 is 1. So I get my c value is 8. Okay, and so I was talking about earlier, we have to be careful where we're going to plug this 8 in. I want to make sure that I plug this 8 into the same form of the equation that I used in solving. In other words, the same form of the equation that I plug my x and y values into. Right? So it's this c value right here that has a value of 8. I don't want to plug an 8 in here. This is a different form of the equation. So this c value is not necessarily 8. This one is here. So I'm going to use this y squared equals sine of 2x plus 8. That's where that c value goes. And then I solve for y by taking the square root of both sides, and I get y equals plus or minus the square root of sine of 2x plus 8. All right? So the difference there is, in one case I was asked to find a general solution. I solved for y, and I still had the c there as a variable. Whereas when I'm asked to find the particular solution, I'm given initial conditions of some sort, and then I solve for c, and I have the variable c is gone here. I've substituted that value in there that I found. All right, so there's an example of a separable differential equation that doesn't result in an exponential growth or decay, and in which we found both the general solution and a particular solution given some initial conditions.